Hello and good morning. We got a whiteboard day today because today we're going to talk about something fairly fundamental, fairly simple, which is binary. Yay, binary! Now, if you've made it this far in your life without knowing binary, congratulations. Well, not a congratulations to you. I'm an educator and I'm not going to congratulate you for not knowing something. But congratulations to all of the software engineers and electrical engineers and designers of all of the systems we use on a daily basis that use binary that succeed, and we can use it perfectly fine without us really needing to know about it. Great. Just like I don't really know all that much about how a car works, and I wouldn't be very useful in repairing an engine on the side of a road, but I can drive around perfectly fine because cars are very stable and they're designed well and they give me feedback when something's wrong, and I can take it to somebody who knows what to do, usually with little lights on the dashboard. So binary is kind of the same way. We don't really need to deal with it, but it's not the same way in that there are things that we do care about, especially as we create software, as we write programs, where knowledge of binary is going to help us understand a lot of design decisions and a lot of artifacts and randomness of an arbitrary facts of using computers that feel random, but that actually aren't random, that are just sort of informed by the fact that they are based on binary, right? That these weren't so much decisions as they are reflections. Data types, in programming systems comes to mind as the immediate example. But so what is binary? Binary is a way to encode numbers, and it's a way to encode data more generally. So binary code refers to we're gonna have a binary system, and I'll get to that in just a second, to store characters, to store string values, to store letters that we can assemble into words and text files and all sorts of things. And binary numbers is going to specifically refer to numbers, and we're going to get to do math with them. Yay. Let's talk about numbers in this video. So, binary numbers. Binary numbers are simply numbers in base 2. Base 2. Now the system we use on our daily basis is in base 10. We have 10 symbols. That we can choose from, and we arrange numbers as a list of these symbols in an order. Let's say I have the number 1024. I have 4 different digits here, 4 different digits, and they each represent different numbers, right? The 2 doesn't represent a 2, it represents the number 20. The 4 represents the number 4, 0 is in the hundreds place, 1 is in the thousands place there. So each number is 10 times larger, it represents a value 10 times larger than the one next to it. So I could have this number out as 4 plus 10 times that, 20, plus 10 times that, 100 times 100, 0 times 100, 0 plus 0, times 1,000. So 1 times 1,000 is 1,000. So 1,000 plus 0 hundreds plus 2 tens plus 4 ones is 1,024. So binary works the same. So we have these 4 digits, and they're each, the place that they're in tells us their value. Binary, of course, works the same way, but we don't have 10 digits to choose from. We only have 2. And we represent them as a 0 or as a 1. We also sometimes use true or false, or maybe dot and dash. We don't use that one, that's a different thing. We use on or off, or high voltage or ground. I don't know. We use all sorts of different representations. But we're going to stick with 0 or 1. Let me draw that nicer. 0 or 1. And that's going to be our representation. So let's write out a number again. I'm just going to pick a random number by just writing some things down. So in this place, in the first place, this is, and these aren't digits anymore. These are now bits. B-I-T. 1 bit is 1 value, just like it's the same word for digit, but in binary. It's a bit. So this bit is the ones place, and it is 0 or 1. So that is that's going to be 1. This bit is the 2 place. It's going to be 2. And now we're not going to multiply by 10. We're going to multiply by 2. So this is the 4's place. The 4's place. 8, 16. 16 times 32 times 2 is 32. 32 times 2 is 64. 128, 256, etc., etc. 512, 194, 2048, blah, blah, blah. And as you talk to people who use computers a lot, you'll notice they all tend to know their powers of 2 up to, at least 2048. Now, I know my powers of 2 up to 2048 because I played this weird mobile game that everyone was addicted to for 4 months, but that's besides the point. And that's it. That's a representation in binary, right? So if we take some number, we would just set this number is now 1 plus 4 plus 8 plus 32. Whatever that value is, and I'm not going to do the math now, that is what this number in binary is. Okay, so how do we do math in binary? Well, we let a computer do it for us because that's how we made the computers. They're very good at it. We can do these operations with mechanical contraptions and logical, electrical symbols, and we can do it really, really fast. But let's go through the example by hand as an exercise. Let's take 2 numbers and add them together. Let's choose 11 and 29. Let's do it in base 10 first. Okay, 9 plus 1 is 10. And immediately we hit our first problem, which is why I chose this number. I can't shove a 10 into this place because I have no symbol that represents 10. Well, I put a 0 in this place. I add any leftover. And then I put the 10 digit up top in the place next to it to be 10 times the value, leaving 0 as over here. And then 2 plus 1 is 4. And 11 plus 29 is 40. Yay! I can do math. Let's do the same thing, but in binary. And you will see that it basically goes the same. Let's take 11 in binary, which is, we're going to use 8 digits of binary. So we have the 1's digit, the 2's digits, and the 4, nothing in the 4, and 8. 8 plus 2 plus 1, yep, that's 11. Sorry, I'm copying it because I wrote these down ahead of time. 29, we have, we have 1, 4, 8, and 16. And I'm sure if we add those up, we would get 29. 16 plus 4 is 20. 8 plus 1 is 9. Yes, we do. Great. So to add these numbers together to get some mysterious result that we don't know about, we just do the exact same thing, but instead of base 10, we do it in base 2. So 1 plus 1 is 2. No, messed up. We don't.
1, 0, 1, 0.
Bender, what is it?
Oh, what an awful dream. 1s and 0s everywhere. Ugh. And I thought I saw a 2.
It was just a dream, Bender. There's no such thing as 2.
This is a 1 plus 1. Well, we don't have room for that in this digit, so we're going to push it into the next one. Not push it, it's going to carry over into the next one. And that's going to happen again. 1 here, and that's going to happen again. 1 is going to happen again, leaving a remainder of 1. Here, happen again. There, and there. Huzzah! So, I picked this number as an example because it had lots of carryovers. So now we need to figure out what this number is. Well, 1 is 0, 2, 4, we have an 8, 16, and we have a 32, 0, 0, and yes, it is 40. We did it. This is the binary representation of 40 right there. Great. So a few questions remain with binary representations of numbers. The two main questions are fractions and negative numbers. How do we represent fractional numbers and how do we represent negative numbers? Let's start with negative numbers. Very simply, we take the first bit, we say that doesn't represent that bit anymore, that represents a positive or a negative sign. and then we just use the other bits to represent the number. Yay. So if this number can represent a value of 256 numbers, perhaps, from 0 to 255, if we got rid of the last bit, it could represent half as many numbers, but also negative. So instead of it being, you know, our number line of possible numbers we can represent, that no longer goes from 0 to 256. It goes from negative 128 to positive 128 or so, plus or minus 1. So we just, well, let me, from zeros here, we just like shift the values. But we still have the same number of possible values that we can store. We just, you know, we cut the maximum, the highest value in half, but we also got that range back on the negative side. Because it's the same, you know, a bit as a positive or negative sign, you know, it's the same amount of data that we can store. So I always thought that was kind of nifty. It's not very meaningful, but it's kind of nifty. The second interesting problem with binary is how we store numbers as fractions. And that's out of the scope of this video. Okay, I don't want to get into math. I do want to get into math. That's why I'm excited. Okay, let's do one more binary thing. And let's ask ourselves a very basic question. Which of these numbers is bigger? Which one is greater than or less than, right? The comparison of two numbers. How might we do this operation? And let's think about it in base 10. In base, is that the number I chose? I chose 29, didn't I? Yeah. In base 10, we can figure out which number is the bigger by going from left to right and just looking for the higher value. We find a negative and a positive value, we immediately know the positive one is bigger. But assuming they're both positive or both negative, we go through and we look until we find a value, a digit is different, and we just pick the highest of that one. Because it doesn't matter what any of the other ones are. If the biggest digit is bigger, you know, 300 something is always going to be bigger than 200 something, right? 300 is going to be larger than 299 because that first place digit is larger. And binary works the same way. So to ask a computer, like an algorithm, to say, compare these numbers and figure out which one's bigger or smaller, we just start at the left and we go. These are the same, these are the same, these are the same, these are different. The bigger one, that's the bigger number. And that's it. So whatever number this is must be larger than that one. Very simple. And that's a little bit about binary numbers. So in the future, we have to go over binary code like ASCII and Unicode and encoding and hexadecimal and, oh my gosh, all sorts of fun stuff that we see on a daily basis, like in real life actually encounter. And that messes up our text files. And we have to go over, well, we don't have to go over fractions as binaries, but like touching on it would be nice because it's something that I often just hand wave and say, don't worry about it. But it is fun to sometimes worry about it and just learn and just demystify the process. So we'll do that as well at some point. But for now, I hope this helped explain binary.